Okay, good morning. Now we'll see how to draw the shear force and bending moment diagram for beams subjected to different types of load. Now this beam AB is a simply supported beam which carries two concentrated loads 30 kN and 20 kN and a uniformly distributed load of 10 kN per meter. We have to draw the shear force and bending moment diagram for this beam. First of all, let us draw the free body diagram. So here support A is a hinge support. You have two unknowns, a vertical reaction and a horizontal reaction, but there is no inclined load or horizontal load externally acting on this beam. So this horizontal reaction HA equal to 0. So the unknowns are vertical reaction RA and vertical reaction RB. So the first step is we have to find out what is the support reactions. So for this, let us take the equation of equilibrium sigma V equal to 0. When you take this equation, you can write RA plus RB is equal to 30 plus 20 plus 10 into 4. Now let us take sigma m about B equal to 0. Algebraic sum of all the moments about point B equal to 0. So what is the moment of RA about B? RA is trying to rotate this momentum AB about B in the clockwise direction. So it is RA into 4 plus 2 plus 2, 8. RA into 8 is equal to 30 into, what is the moment of this 30 kN about B? 30 is trying to rotate this momentum CB in the anticlockwise direction about B. 30 into 6 plus this 20 kN is trying to rotate the momentum dB about B in the anticlockwise direction. So plus 20 into 4. Now this 10 kN per meter acting for 4 meter length is trying to rotate this momentum about B in the anticlockwise direction. So this is plus 10 into 4 into 4 by 2. So from this equation you will get the reaction RA equal to 42.5 kN acting upwards, and RB is equal to, substituting RA in equation number 1, you will get RB equal to 47.5 kN acting upwards. Okay, now we have to draw the shear force diagram. In order to draw the shear force diagram, let us take a section line at a distance XX from the left support. So first of all, you consider portion AC at distance X from A. So let us consider a section line XX at a distance small x from the left side. So now let us write what is the shear force at XX. Now you have got the value of RA as 42.5 kN and RB as 47.5 kN. So shear force at XX is equal to, now what is our sign concept? Our sign concept is right downwards is positive. So left upwards is also positive. So this is plus 42.5 kN. Shear force at XX. Now we have to consider what is the shear force at X equal to 0. That is, shear force at A is equal to 42.5. Shear force at C is also equal to plus 42.5 kilonewton. Okay, so we can draw the shear force diagram for this portion AC. So first you draw the center line of the beam. Now you can take this value as 42.5. So this left portion is 42.5. So at A it is 42.5. There is no load up to this point C. So at C also there is 42.5. It is positive. So above the baseline. Now you consider portion CD. Consider a section line x1 at a distance small x from the left support. So when you write the equation for shear force at x1 is equal to 42.5 acting upwards positive minus 30 acting downwards. So you can write the shear force for portion CD as 42.5 minus 30, which is equal to 12.5 kilonewton. It is acting downwards. So plus. Okay. So we can draw this shear force diagram. Continue the shear force diagram like this. At this point it becomes 12.5. So this value is 12.5. Okay. Now this remains constant up to the point. So this is shear force at C, that is at x equal to 2 meter. Shear force at C equal to plus 12.5 kilonewton. Now let us take shear force at D. Shear force at D, that is at x equal to 4 meter, is also shear force at D equal to plus 12.5 kilonewton. Okay, so this remains constant. 12.5 remains constant up to the point D. So we can drop this point D downwards and we can continue this line. Now you consider a section line x3 at a distance small x from the left support A. You can see this section line x3 at a distance small x from the left support. Now let us write what is the shear force at x3. This is equal to 42.5 acting upwards minus 30 minus 20 minus you have this UDL acting downwards minus 10 into what is this distance? This is actually x distance from the section line is at a distance x from the left support. So we can find out what is the distance of this section line from this point. It is equal to x minus this distance is 2, this distance is 2, x minus 4. So this much distance is x minus 4. From this point to this point it is x minus 4. Okay, so shear force due to this much load is x minus 4, length load is 10 into x minus 4. Shear force at this point x3 equal to. So we can write here 10 into x minus 3. Now we can find out what is the shear force at D. That is at x equal to this is x minus 4. At x equal to 4 meter means shear force at D is equal to 42.5 minus 30 minus 20 minus 4 0. So this is equal to 42.5 minus 50, which is equal to minus 7.5 kilonewton. That is shear force at D. So we can draw the shear force diagram. Minus means we have to draw it below the baseline, which is this value is minus 7.5 kilonewton. Okay. Now we can find out what is the shear force at B. Shear force at B means at x equal to 8 meter. The equation becomes 42.5 minus 30 minus 20 minus 10 into 8 minus 4. 10 into 8 minus 4 is 4. So this value equal to minus 47.5 kilonewton. Okay. So we can draw the shear force diagram. Now here you have seen that the shear force varies with x, the equation of shear force. So that is a linear variation. Now you have got the value at this point B as this is equal to minus 47.5. So the variation is with respect to x. So this value we can draw like this. So this is 47.5 kilonewton. This is positive and this is negative. Now we can hatch this, the shear force diagram for this B. Okay. Now here you can see that shear force becomes 0 at this point D. So you can have an idea that at this point the bending moment will be maximum. Now we can draw the bending moment diagram. So in order to draw the bending moment diagram, we have to write the equation for bending moment for portion AC. Bending moment for portion AC is equal to bending moment at xx is equal to 42.5 into x. Now our sign concept is left clockwise is positive. So this value RA is producing a left clockwise moment. So it is positive. So plus 42.5 into x. Now we can find out what is bending moment at x equal to 0. That is bending moment at A is equal to 0. Now we can find out what is the bending moment at x equal to 2 meter. That is bending moment at C is equal to 42.5 into 2. This is equal to 85 kilonewton meter. So we can draw the bending moment diagram for the portion AC. So at this point A it is 0 and at this point C it is equal to 85 kilonewton meter. So we can join here. You can see the bending moment varies with x, so it is a linear variation and this value is plus 85 kilonewton meter. Now let us write bending moment for portion CD. Bending moment at x1 is equal to this 42.5 into this distance x. It is producing a clockwise moment minus 30 into x minus 2. This distance is x, this distance is 2. So this much remaining distance is x minus 2. So we can write the equation as bending moment at x1 is 42.5 into x minus 30 into x minus 2. So bending moment at x equal to 0, that is at A is equal to we can find out what is bending moment at C, that is at x equal to 2 meter. Substituting x equal to 2 meter in this equation, you will get this is equal to 85 kilonewton meter. And bending moment at D, that is at x equal to 4 meter, this value you will get 110 kilonewton meter. Now we can draw the bending moment diagram. So the bending moment diagram we can continue as this value is equal to 110 kilonewton meter. So this variation is linear. You can draw like this 110 kilonewton. Now we can write the equation for bending moment for the section x3 as 42.5 into x minus 30 into x minus 2 minus 20 into x minus 3 minus 10 into x minus 4 the whole square by 2. So when you substitute the value at D at x equal to 4 meter, you will get MD equal to 110 kilonewton meter positive and at B it is equal to 0. Now we can draw the bending moment diagram. So here the variation is parabolic and we can draw it like this. Okay, this is C.